Hello students, my name is Dr. Gajendra Purohit and I upload videos for engineering mathematics B.Sc on our YouTube channel. So if you are preparing for any competitive exam where higher mathematics is asked, then our YouTube channel is very helpful for you. I will explain you how to solve partial differential equations using the Fourier Sine Transform. But before this I had also explained you how to solve a partial differential equation using Fourier Cosine Transform, and if you haven't seen that video yet, then you should watch it first. When do we use Fourier Sine Transform? I had explained you that whenever we have any partial differential equation question and some specific conditions are given in the question, then we will apply the Fourier Sine Transform. I will also try to explain this here. So let's begin now. If there's any partial differential equation given, then I had told you that there is some change in Laplace and Fourier. Laplace is always taken on t. Fourier is always taken with respect to x. If we have to calculate del 2u by del x square, we need to apply Fourier Sine Transform. Its formula will be root 2 by pi. It will be as u 0t minus s square u bar s. I have explained for cosine previously. This is how you apply the Fourier Transform. Now you'll see the condition from its formula itself. And if u0t is given in any question, we will apply the Fourier Sine Transform. If in any question ux0t, it means del u by del x at x is equal to 0 is given. In that case, you will apply the Fourier cosine here. If both conditions are not given and x is between minus infinity to infinity, then we will apply only Fourier Transform. And you don't need to worry about t, because as soon as you apply the Fourier Transform, this u will convert to u bar. So x will become s here. You don't need to apply any formula because the Fourier Transform is always applied on x and it is not applied on t. Now pay attention here. Therefore, if in any question you need to apply sine or cosine in the Fourier Transform. So in that case, while solving the partial differential equations, if u0t is given, then we will apply the Fourier Sine Transform, and if ux0t is given, then we apply cosine. I have already explained Fourier Cosine Transform. Today I will explain you how we solve the question by applying the Fourier Sine Transform. If u0t or u at x equals 0 is known, then we use the infinite Fourier Sine Transform. Clear? And like here, if ux0t or del u by del x at x is equal to 0 given, then the infinite Fourier Cosine Transform is used, right? I hope you all have understood this. Now, I will try to explain you with a few questions given here. Like here it is del u by del t and del 2u by del x square. This is a heat equation where this condition is given, and u0t, ux0 and ux, t is bounded. These three conditions are also given. So we have to check this first condition. Now u0t is given here, which means we will use the Fourier Sine Transform. How will we do it? Whatever question is given on its both sides, we will apply Fourier Sine, okay? So the formula for Fourier Sine is equal to del 2u by del x square. So students, what will we get here? Look, this will become du bar s upon dt is equal to, the formula will be applied here, right? And here I just told you, what is the formula of this? Its formula is 2 by pi s u 0t minus s square u bar s. Note this down. So students, this is what we have as the formula for Fourier Transform, which I just explained to you. What is its value given here at first number? It is 0. So what will be the value of this? So we will put 0 here. Now which differential equation is left? It is du bar s upon dt is equal to minus s square u bar s. So what will we do here? We will separate the variables and we will integrate it, right? And then we will get log u bar s is equal to minus s square t. Here we will take log a. When log a will come here, it will become log a minus log b. So log u bar s upon a, and when we will remove the log, we will get u bar s. When we remove log, this will become e to the power minus s square t. And this a will be cross multiplied over here. So we know what it means. We know it means that the Fourier Sine Transform of uxt is equal to a e to the power minus s square t, and we have got the answer. So this is the answer, students. Now what we need to do here, just find the value of a, and equation number 1 is the answer, not the actual answer, but you can consider this equation as the answer in a way. Let's assume this is 1 and this is 2. So equation 2 is our answer here. Clear? Now what we have to do is find the value of a. To find the value of a, we will use this second condition given here. So what will be the next step now? We will put 0 in place of t, then Fourier Sine Transform of ux0. This will be e to the power 0. Therefore, we will get a here, right students? This is x. Now this ux is given equals to 0. So if I take its Fourier Sine Transform, so the value that we will get here will be equal to a. We just need to substitute 0 in place of t. So after this we will apply the Fourier Sine Transform. So it will be u x t, and what will be here is equals to under root of 2 by pi, 0 to infinity. This will be u x t, and then here we will get sine sx dx. But students, if you haven't seen the video on Fourier Sine Transform yet, then please watch that video first from the I tab. Now you have to find the value of this term here. So what do we need? We need 0 instead of t. Because ux is given 0, so what will we do? Wherever there is t, we'll put 0. So what we will get here? We will get 0, right? So when we will find its value, then what will come here? Fourier Sine Transform of u x 0 is equal to under root of 2 divided by pi, and the value of this term is given as 1, between 0 and 1. So here the limit will be from 0 to 1, and when we will put the value as 1, what we will get? Sine sx dx, right? This will be root of 2 by pi. And the integration of sine is minus of cos sx upon, it will be s. The limit will be from 0 to 1. Now, first of all, we will put 1 here. So we will get cos s upon s. On putting 0, it will become 1. We will get this value. Take minus inside. This will be root of 2 upon pi into 1 minus cos s divided by s. So students, this will be the value of fs ux0, right? And we know, if you will check from here, so the value that we will get, it is coming a, and on solving, we are getting this value. This means a is equals to root of 2 by pi 1 minus cos s upon s. This value of a needs to be placed here. So what will be the answer we will get from here? So students, it will be Fourier Sine Transform of uxt. The value of a will be placed here. So this will be root of 2 upon pi 1 minus cos s upon s e raised to the power minus s square t. But the partial differential equation is given in terms of small u. This is given in terms of uxt, then the answer should also be in terms of uxt. So we will take its inverse Fourier Sine Transform. Now I'll explain the formula for the inverse Fourier Sine Transform. As you know, this is the formula for the Fourier Sine Transform. So formula for its inverse will be fs u st. Here we will get is equal to under root of 2 upon pi. And this will be from 0 to infinity. From here, its value will be, that will be u st, and it will be sine sx ds. You need to understand this. We are taking the integral in respect with s. When we apply inverse here at this point, its integration is done with respect to s. When Fourier Sine Transform is given, then we do with respect to x. This value is given. Now what will we do? We need the inverse. So as you will apply the inverse here, what will be its value? So it will be Fourier Sine Transform of u st. It is equal to, here note one thing, that the value we will get here is in form of uxt. This is the value which we will get with inverse. As you can see, the formula is given. This is the formula, right? So now we will take this particular value and substitute it here, okay? As we will put this formula, root 2 by pi into root 2 by pi will be 2 by pi. And then from here we will get its value, limit from 0 to infinity, 1 minus cos s divided by s, e to the power minus s square t sine. And here it will be sx dx, right? So we have the answer for this. And in this same form, you have to write it down, right? So in this case, you need to understand that whenever you have to apply Fourier Sine Transform, so we find it this way. And if we have to find the inverse, then we can solve it like we just solved. Clear? If you look at this question, I have explained it to you here by following a method. You can see that we got a here. We solved it and got this value of a from here. Now we will put this value of a, right? Okay, so this will be its answer, right? Now we will find its Fourier inverse Sine Transform. So we will get this as its answer, right? So these are our books which are available on Amazon and Flipkart for CSIR, NET and IIT-JAM preparation. General aptitude book is also available. So you can buy it from Amazon or Flipkart. One more question, del u by del t is equal to k, del 2u by del x square, where x and t is greater than 0. If you look here, one condition is given at x is equal to 0. Whenever we talk about Fourier Sine Transform or Fourier cosine, so to find any of it, we should know the condition that what is given. Is it given u or del u by del x? So here it has been given u at x is equal to 0. So what we will use here, Fourier Sine Transform. So what will we do on both sides? Apply Fourier Sine Transform. So del u by del t, this is equal to k, and Fourier Sine Transform. It will be del to u by del x square. So students, here this will become du bar s upon dt. K. So from here, what is its formula? It is root of 2 by pi su in bracket 0t minus s square. It will be s square u bar s. Is it clear? Now, see here when at x is equal to 0, u is given 0. So what will we put as its value? We will put u equals to 0. So we will get du bar s upon dt, this k will be put inside. And we will take this value on this side. So it will be plus k s square u bar s is equal to. From here we will get k s and its value is given u is equal to 0. So u0 and here it will be root of 2 by pi. So you can see we have a differential equation here, and what type of differential equation is it? We are getting this as linear in u. So what we will do is find the integrating factor, right? So the integrating factor will be e to the power k s square and it will be dt. It is p dt, right students? So we will get e to the power k s square and t here. We know that this is linear in u bar, so we know what will be its solution. It will be u bar. So here we have u bar s dot if. This is equal to if dot q dot dt plus. Take a here, clear? So we will take this u bar s dot, here it will be e to the power k s square t is equal to the integration of e to the power k s square t, and what we are getting as the value of q, it is k and s u0 2 upon pi dt, and here it will be plus a. Now here this will be u bar s and e raised to the power k s square t is equal to, what will we do here? This k here su0 2 divided by pi is a constant. Its integration will be ks square t upon ks square, and here plus a will come. And this is what we have here as its value. We will divide this. So students, here we will get Fourier Sine Transform and we write it as uxt, clear? This is what we get. We will divide this. So this will cancel out. And here k is cancelled out by k, so it will be u by s. And here we get the value as 2 divided by pi plus a e to the power of minus k. And here as squared t. So here a condition is given that at t equals to 0, u is given 0. So we will put 0 at place of t. So students, here it will be fs ux 0. When we will put t as 0 here, then we will get the value as u bar upon s. Root of 2 divided by pi, clear? So from this, we will get the value here, u0 by s into 2 divided by pi plus a. So let's highlight this value, which we have obtained here after solving. Since the answer has value of a, so we are solving it to find the value of a. Now the condition which is given. From that, we'll find this value of Fourier. We know that if we have 2, find the Fourier Sine Transform. Suppose uxt is given. So what is its formula? It is root of 2 divided by pi. This is 0 to infinity, and here it will be u xt and sin as x dx. And what is the value of this u given here? If we put 0 in place of t, because what I have to do. So if we will put value of t as 0, it will be 0 here. And when t is equal to 0 here, what will be the value of u? It is 0. So the whole thing will become 0. So we will get its value as 0. And this is its value here. So what will be the value here which we calculated? It is 0. So we will consider this as equation 1. And let's take it as 2. And this as 3, right? So here by 2 and 3, right? If we take this value and this value, which are equal to each other, so these will also be equal to each other, which means equal to 0. So if you will solve it, what we will get here? u0 upon s. Root of 2 by pi. Plus it will be a is equal to 0. So the value of a we will get, it will be minus u0 upon s root 2 by pi. We will substitute this value of a here. So we will get the Fourier Sine Transform value of u xt, right? So this value will be xt, clear? And this will be u0 upon s root of 2 by pi. And here we will get the value minus u0 upon s root of 2 by pi e to the power of negative ks square. And here t. So what will we do here? This u0 upon s we will take out root of 2 by pi. Okay, from here it will be 1 minus ks square and t. So this will be the Fourier Sine Transform of u xt. But what do we need? We need the value of u xt. What will we do here? We will take inverse Fourier Sine Transform, right? So as soon as we apply it, and we know the formula for inverse sine transform, we know that if we will take the inverse, so it will be u xt. So this is how we indicate its Fourier Sine Transform here. Is it clear? So we'll find its inverse Fourier Sine Transform. And its formula is limit from 0 to infinity. Root of 2 by pi, this will be u bar, st. And here we will put sine. S x into. It will be ds. Now take this value and put it here. And when you will substitute it, so the value we will get here, we will put this term as it is here. So this u bar upon s will come outside here, and then root 2 by pi into root 2 by pi. It will become 2 upon pi. And this u0 will come outside. And this will be limit 0 to infinity. And its value will be 1 minus e raised to the power minus k. S square t upon s, right? This s will come here. And then what we will write here? Sine. And then s x ds. And this is what we get as the final answer. In this way, we can solve this partial differential equation using the Fourier Sine Transform. This question is for the comment box. How many seconds did you take to solve it? Please let me know through comment. You can check out the videos of this complete series. So you can check the playlist from here if you are preparing for CSIR, NET, GATE, IIT-JAM and want to improve your general aptitude. You can watch this series, and from here, you can subscribe to my channel. Thank you so much for watching my video, and I request, please do subscribe. Thank you.